Okay, let's dive into this. Picture a hyper-macro slow-motion shot of a golden bread crust tearing open. You can almost see a delicate wisp of steam escaping, right? Catching the light as these microscopic crumbs tumble through the air. Now, hold that image in your head, because in the next 60 seconds, just while we begin this explainer, over 1 million slices of this ancient staple are going to be sliced, toasted, and eaten all around the globe. I mean, it is the absolute cornerstone of human survival. Its ingredients are literally older than recorded history itself, and yet it costs just pennies to take home. What you're about to witness today is a masterclass in extreme biological engineering.
Section 1. The bread miracle, hiding in plain sight. Think about that simple, rectangular loaf hiding right in plain sight on your kitchen counter. Underneath that soft golden crust is a cellular sponge that completely defies the sheer chaos of nature. You see, producing this flawless staple doesn't just happen by accident. No way. It requires immense mechanical force combined with microscopic biological control. It's this incredibly violent collision of raw agriculture and intense manufacturing logic. Which brings us to the ultimate question behind this whole entire process. How do you bake millions of perfect loaves a day? Just think about the paradox here. We've got a product that feeds the world, from school lunches to artisan sandwiches, and it's manufactured at lightning speed with absolute uniformity every single time. Making it isn't just about tossing together some flour and water. It's about taming a living organism inside a terrifyingly fast mechanical gauntlet.
To really understand the scale of what we're talking about, you have to look at this number, 1 million. And actually, scratch that, this isn't an annual or even a monthly production figure for some global brand. That is the staggering output of a single modern facility in just one 24-hour shift. Imagine flying a drone over one of these sprawling industrial campuses, flanked by towering silver grain silos. They are pumping out over 1 million globally standardized loaves every single day.
Let's move to and see how this builds. Section 2. The mechanical gauntlet, surviving the factory floor.
Because getting to that million loaf mark requires surviving the factory floor. Imagine the deafening roar of pneumatic tubes running continuously overhead. Outside, you've got tanker trucks reversing, their warning beeps cutting through the constant hum of the facility, and they are pumping literal waterfalls of pure white flour into the building. The journey starts with hundreds of tons of this raw flour blown through miles of stainless steel piping. But listen, this isn't the ordinary milled wheat you bake with at home. Oh no, it's an advanced, highly proprietary blend formulated specifically for extreme elasticity. And the quality requirements here, they are ruthless. There is absolute zero tolerance for error. If the protein or moisture content is off by even a fraction of a percent, the cellular structure of the dough will completely collapse. That one single error would bring a multi-million-dollar production line to a grinding, catastrophic halt.
Once that flour actually passes inspection, the journey gets incredibly violent. It starts with high-speed mixing. Massive steel arms beat a 2-ton avalanche of wet dough with just staggering torque, developing this critical gluten network in mere minutes. Rhythmic, heavy thuds literally shake the concrete floor under your feet. Then, boom, we hit the volumetric divider. A high-speed blade chops this continuous river of dough into thousands of exact, identical pieces every minute. It seriously sounds like heavy machine gun fire. In a fraction of a second, the raw mass is scaled, rounded, and dropped into an endless marching line of heavy steel pans.
Section 3. Bioengineering the dough, taming the microscopic. Now, what's really interesting about this slide is a raw lump of dough cannot become bread through violence alone. We have to slow down. The violent mechanics fade away, and we enter the realm of delicate biology. We transition into the proofing tower, which is this towering, climate-controlled spiral where the true bioengineering actually takes place. Look closely at the biological reality of yeast inside the crumb of any slice of bread. It's not a solid thing. It's a matrix of thousands of tiny air pockets. Inside that proofing tower, millions of dormant yeast cells finally wake up. They start consuming sugars and exhaling carbon dioxide, expanding the dough to 3 times its size. Now, shrinking this proofing time by just a few minutes would save the industry millions of dollars, but you just cannot rush nature. The biological reality of yeast strictly dictates the speed. The temperature and humidity absolutely must be maintained flawlessly, because a shift of just a single degree, that could cause 1 million loaves to instantly deflate.
Section 4. Perfection at scale. Zero tolerance justice.
Okay, once the biology has done its job, we ramp the speed right back up. The dough enters a 150-foot-long tunnel oven, and when it exits the other side, it is just a blur of golden crusts passing under intense strobe lights. We are back to staggering velocity here. This is the ultimate test of perfection at scale. Because at this insane speed, you simply cannot rely on human eyes to spot a defect. We are just way too slow. And this brilliantly illustrates the solution. Quality control is entirely relinquished to machines. Every single baked loaf passes beneath this massive array of 3D vision cameras and thermal scanners. A hypersensitive AI algorithm calculates the exact volume, crust color, and symmetry in milliseconds. If a loaf is too short, or maybe the crust is just a shade too dark, bam, an automated pneumatic arm executes zero-tolerance justice and blasts that defective bread right off the line.
The survivors of that crazy inspection gauntlet immediately hit the packaging timeline. Within 10 minutes of exiting the oven, they are descending massive cooling spirals. Stripped of their heat, the loaves are forcefully pushed through vibrating razor-sharp bandsaw blades that are slicing at invisible speeds. Then, automated mechanical arms, these completely silent high-speed robots, bag and seal the bread in a literal blur of plastic and twist ties. They are boxed, stacked, and wheeled directly into a fleet of waiting trucks, ready to be dispatched before the sun even rises.
The golden stream of bread flying off these lines looks like a fast-moving river of wheat. And the scale of this operation, it truly challenges human comprehension. To put that into perspective, if you took a single day's output from just one of these 24/7 facilities and laid the loaves end to end, that trail of bread would stretch all the way from New York to Chicago, across half the country. And they do this 365 days a year, feeding entire cities before the residents even wake up. Section 5. The human pulse, the invisible conductors.
But let's pause for a moment, take a breath, and step back from the deafening roar of the pneumatics, the blinding speed of the robotics, the sheer mind-boggling scale of it all, because beneath the surface of this industrial giant, there is a distinctly human pulse. Behind soundproof glass, you have master bakers in white coats staring at cascading waterfalls of data, monitoring complex oven telemetry. Out on the floor, technicians navigate the aisles armed with digital thermometers and humidity sensors. They are the invisible conductors of this massive biological symphony. Throughout the night shift, these experts are constantly tweaking oven zones by mere fractions of a degree. They are dynamically adjusting the entire factory's environment just to compensate for a change in barometric pressure or weather happening outside the factory walls. It really is a beautiful marriage of human intuition and industrial power.
So the crucial point is, Section 6, the bakery of tomorrow, the closed-loop system. This operation never stops evolving. The bakery of tomorrow is already taking shape right now as we speak. AI algorithms are currently being deployed to analyze local weather patterns and historical buying habits. They are predicting exactly how much bread a specific city will buy on, say, a rainy Tuesday, all in a massive effort to eliminate overproduction before the dough is even mixed. And perhaps the most incredible evolution of all is the life cycle itself. It's becoming a true sustainability miracle. Unsold bread isn't just tossed into a landfill anymore. Nope. It is reclaimed, processed, and transformed into renewable biogas. That gas is then fed back into the system to power the very ovens that baked it in the first place. It's a brilliant closed-loop system that drastically slashes food waste, quite literally turning yesterday's leftovers into tomorrow's energy.
It is an absolute triumph of industrial design and biological mastery. It's a violent collision of raw agriculture, living microorganisms, and microscopic precision, all moving at a speed that absolutely defies logic. So the next time you pull a slice from the bag, toast it up, and smell that comforting, familiar aroma, take a second look. You aren't just making a sandwich. You are holding a modern engineering miracle right there in the palm of your hand. Which kind of makes you wonder, what other staggering miracles of extreme engineering are sitting quietly in our kitchen pantries right now?